In this video, I'll be taking a look at the input files associated with a sub-council area projection focusing on Aberdeenshire. I'll be looking in detail at the input files that comprise both the training projection and the continuity projection provided in the documentation for sub-council area projections provided in this project. I'll also be showing how one can update POPGROUP to make use of input files provided as standard by the improvement service going forwards as new demographic data is released. So I have my input, output and skeleton files for Aberdeenshire that I set up in the previous video. And now within the input folder, I've copied all of the relevant files that are used to produce the sub-council area projections for Aberdeenshire. So these relate to the first set of projections that National Records of Scotland produced starting in 2011 and going 25 years into the future. So in the future, these files will be provided by the Improvement Service with updated demographic data and assumptions. So one of the first things one has to do after copying these files into the input folder is to make a fix in POPGROUP to allow these input files to run. One of the issues at the moment is that all of these folders have a whole set of POPGROUP system macros and programs attached to them, which don't align correctly to the folder that these input files are currently stored. So one of the first things we have to do is make use of a file called POPGROUP update model folder to realign the system files with the new input folders that we've copied into this particular folder. So I can open up this file. I need to select the family member from derived forecasts to POPGROUP. And then I need to know where the system files are actually stored on my computer. So I can double click on that cell and navigate to forecast and then POPGROUP and to the PG system files. Click on OK and that path now appears in this cell. I need to say where the skeleton files for the POPGROUP model I'm concerned with reside, and these are also within POPGROUP, and I need to select the Aberdeenshire folder. I now need to select the input workbooks, which again are in POPGROUP. Select the appropriate folder, click on OK, and then finally a note to say where the output folders are. So again, I can navigate to these relatively easily and then select OK. So this will just update POPGROUP systems so that I can run these input files and they will draw on the appropriate system files which are stored on a particular part of my computer, which differs to the place on the person who created these input folders computer. So clicking on update system folders will make all those changes for me. That will take 5 to 10 seconds to run. But once I've run this, then I'm able to include those input folders in a projection myself. So I can now close this folder, don't need to save the changes, and I can now start exploring the input, output and the input files themselves. So I can now take a look at the input files for the Aberdeenshire sub-council area projection. And the first thing to look at is the two scenario folders. So the first scenario is the training projection. So this is the projection that is run over a historic period where we have access to data on births and deaths, and we can use that information to calibrate the local differentials in fertility, mortality, but also to estimate migration for our local area. So let's have a look at the scenario folder to see the training scenario to see which files are specified. So the final year for this forecast is 2012, which is the start essentially of the continuity projection. We can see a base population provided here, information on births, deaths, and mortality. So what I'll do now is look at each of these files in turn. So first of all, the pop base 1 folder. So if I open this folder and look at the data, one can see that we have data for each of our areas of Aberdeenshire, all 19 of them. We have this by age. The base year for the projection is 2001. And so we're running the projection from 2001 up to 2012. The fertility is specified in the training projection by the file fert1. So if we have a look at that, what we can see here is we have a standard schedule which relates to fertility for Scotland. We don't have any data entered, or we have in the Aberdeenshire sheet we have some differentials which capture the trend in fertility, but these are actually applied from 2012 onwards, so they don't apply to this particular training projection which runs from 2001 to 2012. But the key thing that this projection does have for the period 2001 to 2011-12 are the estimates of total births, distinguishing males and females in each year. So we have counts here, so our projection is going to be constrained to these counts of births. And what's useful is that will give us information on how we need to adjust our schedule for Scotland in order to create the counts of births observed in each of our 19 areas of sub-council areas of Aberdeenshire. And similarly, if we look at Mort1, so again, we have this standard Scottish schedule giving rates of mortality for Scotland. And then in each of our sub-council areas, we have information on the deaths that occurred here by 5-year age groups, running all the way up to age 85 plus. So again, POPGROUP, when it runs this training projection, it uses the standard schedule to estimate fertility, and in this case mortality. But this provision of data on the counts of deaths provides an adjustment to the effect of that standard schedule to replicate the numbers of deaths in each of our sub-council areas within Aberdeenshire. So through this training projection, we estimate an adjustment to the standard schedule to replicate the deaths that were observed in practice. We also have information on in and out migration. And if we look at these files, so again, it's the files that suffix with the ending 1, so MIG in MIG1. So that's the in migration in our training projection. And these files only contain the standard migration schedule. So if we look in our local areas, there's no data that is entered here. So we don't have any migration data. And similarly, for our out migration file that is used in the training projection. If we take a look at that, again, we just have our standard migration schedule for Scotland as a whole, and we don't have any data for our sub-council areas. So this migration for the sub-council areas, we need to estimate using our training projection. We also have some special groups which are defined here in Special Populations 1. So if we take a look at this file, this contains data on the prisoner population within Aberdeenshire. We don't have any data on students or armed forces. And that prisoner population is provided for with age detail, and we can see that it applies to one particular group here. So one particular sub-council area within Aberdeenshire. So our training projection specifies one more file that we need to look at, and it's quite an important one in terms of the methodology of the sub-council area projections, and that is this constraints file. So we have information on births, including local births. We have information on deaths, including local deaths in each of the 19 sub-council areas. We're using a national schedule of migration, which may not apply locally, but we don't have any information that we can feed into that on migration. But this constraints file is what allows us to estimate local migration. So if we have a look at Cons 1, open this up, Cons 1 actually contains the population counts by sex and age for each of the sub-council areas within Aberdeenshire. So here I'm looking at Aboyne, Upper Deeside and Donside, and we can see that these ticks indicate that the population by age and sex is provided in 2002 all the way up to final year of the projection 2012. And we can see these counts of population entered here. So these are taken from the National Records of Scotland mid-year estimates and entered here. So crucially, the POP group methodology, after it's applied its national schedule of migration, after it's applied the local counts of births and local counts of deaths, POP group forces the projections to replicate these mid-year estimates, and in doing so it makes an adjustment to migration, which POP group then captures, and that's what we use as our local estimate of migration in the following continuity projection that's informed by our training projection. So that's all the input files that are used in the training projection. Let's now move on to our continuity projection. So I can open up Scenario Continuity Aberdeenshire and look at each of the files that we use in this projection. So this is the continuity projection that is informed by the training projection. And we can see now we have a final year for this forecast as 2037. So we're starting in 2011 here. So we have the same POP base folder, but we have different folders for fertility and mortality. So fertility is based on FERT2, mortality MORT2, and we can see that our migration files are also based on different folders, each with the ending 2, whereas in the training projection these ended 1. So we've got different assumptions here, and similarly for the special populations, and also for the constraints we have a different file that's being used. So let's have a look at each of these and understand what the differences are. So starting off with POP base 1, So in pop base 1 we're taking 2001 as our base population. So the same file as we used previously, but in this projection we're projecting all the way up to 2036. The FERT2 folder well, this has a national schedule of fertility rates. But if we look at each of the sub-council areas here, we have a differential. So in this particular sub-council area, which is Arboyne and Upper Deeside, we can see that we have the estimates of the observed estimates of births between 2001 and 2012. But then going forwards from 2012 up to the end of the projection period, we have a differential. And that differential is assumed to be the same over the projection period. And the differential is 1.12, indicating higher levels of fertility in this particular sub-council area compared to the national schedule. If we look at the Aberdeenshire sheet, we can see that there are also some differentials here. And this differential is capturing the trend in fertility that is expected across Aberdeenshire. So that's capturing an assumption about change in fertility over time at the sub-council area level. And that same time trend is applied to each of our sub-council areas. If we look at another sub-council area, we can see here in this sub-council area we've also got higher fertility than in the national schedule. So these increases or these increases in or these differentials here are informed directly by our training projection. So where we produced the projection between 2001 and 2012 using a national schedule of data, but we had observed total births, so we could see what adjustment do we need to make to the national schedule in order to get the observed totals of births. That's what informs the differentials that we see reported here. So we see a similar thing for mortality and migration. I'll just have a look at the mortality 2 folder. So again, we have a national schedule of rates. If we look at the Aberdeenshire sheet, what we have here are a set of differentials that capture the change in mortality over time, and these are by age and sex for Aberdeenshire. So that's the projecting forward recent changes in migration at the council area level, and that same time trend is applied then to each of the sub-council areas equally. If we look at the sub-council areas, we can see that these include a differential. So here for this particular council area, we have a differential of 0.9. So it's a total differential that applies to all age groups. And it suggests that our training projection indicated lower levels of mortality for this particular sub-council area compared to the national schedule. And we assume that same differential between the national schedule and the sub-council area mortality holds for the duration of the projection. We can also look at the migration files associated with the continuity projection. So here we're looking for MIG in MIG2. I can open up that folder. And we can see similarly to the mortality and fertility files, we include a different file here for migration compared to that used in the training projection. But the assumptions here are informed by the training projection directly. So we can see that we have a set of schedules here for each of our sub-council areas, So really what this folder is doing is it's capturing the local differentials in migration from the national schedule that we estimated using the training projection itself. We have a different special groups population. So if I open that up, we can see that now we have the prisoner population not just for 1 year, but for all of the years of our projection period. And the assumption here is that that special population remains constant over the projection. So the final file to look at is our constraints file. And again, we have a different folder here, a different file, cons2. And if we open that up, we can see what cons2 is doing. So for cons2, we have a whole set of data that applies to Aberdeenshire. So we have the age and sex population counts for Aberdeenshire running from 2013 onwards. So this is the constraint that we make to our subcouncil area projections to ensure that if we add all of the population counts for our subcouncil areas, they should sum up to the projections that are produced for the council area. So all of the 19 areas in Aberdeenshire in our projections will sum to the projection that National Records of Scotland produce for Aberdeenshire as a whole. So that's a quick look at all of the input files that are involved in both the training projection and the continuity projection.